This rare video shows NASA engineers performing reduced gravity motion experiments using a specially equipped KC-135 aircraft. The KC-135 can perform parabolic flight movements resulting in brief periods of weightlessness or near weightlessness, originally used by the Air Force for in-flight refueling. NASA was given several of these KC-135 aircraft over the years for zero-G motion experiments. Since the moon's gravity is only 1/6 of Earth's gravity, experiments of this kind gave NASA valuable information to help predict what it would be like for astronauts to maneuver on the lunar surface.
The LRV would be a two-man, four-wheeled vehicle, 10 feet 2 inches long, 44 inches high, with a 7.5-foot wheelbase, weighing 460 pounds earth weight, and capable of carrying a total payload of 1,080 pounds. The LRV would have 5 major systems: mobility, cruise station, navigation, power, and thermal control. The mobility system, which must be able to cross 12-inch high obstacles and 28-inch diameter craters, consists of the wheels, traction drive, suspension, steering, and drive control electronics. The system was designed, developed, and tested by General Motors. The LRV tires are made of a woven mesh of zinc-coated piano wire, to which titanium threads are riveted in a chevron pattern to keep the wheels from sinking into the soft lunar soil. A mobility test unit was used in early phases of development to validate the LRV mobility system. Two 36-volt silver zinc batteries provide the vehicle's power. Each wheel is individually powered by a 1/4 horsepower electric motor. A highly efficient harmonic drive system, originally developed by the U.S. Shoe Machinery Corporation for other purposes, is used with each motor, eliminating the need for a transmission and its gears. The suspension consists of a damper or shock absorber supported by triangular arms that pass the suspension loads to torsion bars. A simple navigation system, which would allow astronauts to drive beyond sight of a lunar module and yet be able to return to it by the most direct route. The system works by recording direction and distance traveled from a starting point. In order to assure the proper physical relationship or interface between the vehicle and the astronauts in their pressurized spacesuits, several so-called cruise station reviews were conducted, first in normal Earth gravity conditions and later in simulated 1/6 G. For other cruise station reviews and development testing, an LRV mock-up was installed in a KC-135 aircraft which flew parabolic flight paths. This provided brief periods of low gravity, simulating lunar conditions. One example of interface problems was the initial difficulty in getting onto and off of the LRV. Addition of a simple tow hold plus astronaut training proved to be the solution.